why I didn't use it, the butterfly valve, in the vertical line instead, and I'm using in the horizontal line. There is a reason for that. I just forgot to add the inner diameter, so you can use, it's a butterfly valve is a full bottle, so I will use the same size, inner size. Okay, so inches. Okay, now it's converted. Now it's something very important to you understand. In the schematic, the valve is shown in the vertical line. Not necessarily it is installed in the vertical line because it is a schematic. What it will tell you if this valve is on vertical or on horizontal is the isometrics, is the more reliable document to verify the arrangement of the system after going to the field and verify by your own eyes, okay? Because sometimes when we do plan design, the project documentation are built, but there are some changes in the field, and eventually the documentation, the project documentation is not updated. So if you are in a industrial facility, if you are in a production, in a process that already exists, get the documentation, but always go to the field to verify, to match if everything matches one with another. Okay, the same for pipe instrumentation diagram. And here it's a matter of experience. Imagine this: a butterfly valve is a valve that opens this way. It's closed. We have the tube here. We have the tube here, and in this position it's closed. To open that, you need to change to turn around the hand, to turn around the valve in order to let the liquids flow to the system. Okay, so you need to do this. It's the same principle that we use in ball valves. During commissioning in startup, usually we fill the tanks or the vessels with the isolation valve closed. And now imagine if we have 2 tons of water in your tank, how will you be able to turn around the manual valve? Because there will be much pressure in one side and almost any pressure at the other side. So to prevent that, to let the life of the operator easier, instead of having the acceleration or the gravity working against you, we add that to the horizontal position, because now this way the forces in the valve will be much lower, and now to open the valve will be much easier than doing in the vertical line. Okay, eventually to be able to do that, you will need to have a series of engines to use to be able to apply the force that is needed to turn around in the vertical line, in the vertical arrangement. In the horizontal, no, it's by human strength you are able to open and close the isolation valve. Okay, stay aware of that. It's something that you only learn when you go to the field and you have a lot of lessons learned to your life. So now here you find that for free.